Hi everyone, my name is Angelo Neves. I'm gonna present the paper titled Automatic Construction of Benchmarks for RDF Keyword Search System Evaluation. The paper is about an automatic method to generate benchmarks to assess RDF keyword searching systems. In this presentation, I'll first define what is RDF keyword search. Then I'll review the method, show you how we optimize it, present the results of the experiments we've conducted to evaluate the performance, and finally, comment on some conclusions. Now I'm gonna define what RDF keyword search and its answers are. An RDF dataset is a set of triples with a subject, a predicate, and an object that induces a graph. Now consider the query character Meryl Streep movie out of Africa. An answer for this query is any subgraph of the dataset containing keywords, not necessarily all of them. For example, this subgraph is a possible answer. It covers all keywords and seems to be an exact answer to the intended meaning of the query. An alternate answer could be this one. However, it doesn't cover all keywords. The last answer example seems not to refer to the movie Out of Africa, since it doesn't include its keywords. If necessary, one can omit it by selecting only the answers with the greatest keyword coverage. Researchers usually use benchmarks to assess search systems. Examples of existing ones are Dosso and Silvillo for RDF datasets and Kaufman and Weaver for relational datasets. However, they are not always available online, are incomplete, and are mostly not RDF specific. Developing new benchmarks to avoid such problems is extremely time-consuming. An example of benchmarks incompleteness is Kaufman's query number 43, which is Mauritius, India. Kaufman defines as the ground truth for this query only the organizations that both countries belong to. However, there is an additional answer that refers to the geographical relationship between them. We then propose an offline method that automatically creates benchmarks, queries, and their respective ground truth answers for a given dataset. The method is composed of two parts, one to generate queries and the other to generate the answers for each query. Let's see an overview of the query generation method. First, one selects user-relevant entities called inducers. India is an example of an inducer. Next, one computes a neighborhood graph for each inducer. Finally, one computes set of keywords randomly selected from literal values of the nodes and edges properties. Some examples of queries are Mauritius, India, India religion language, and India river city. Now, let's see an overview of the answer generation method. Let's take the previous example dataset and the character of Meryl Streep movie Out of Africa. First, one selects the seeds, the grid nodes in this picture. A seed is any node whose property values match with some keyword. For example, node A matches with keywords out and Africa. Node B matches with movie, and so on. Second, one computes the power set of the set of seeds. Any possible valid answer contains at least a subset of the set of seeds. Third, for each subset S from the power set, one computes all paths between pairs of seeds in S. The set of triples obtained is a solution generator. Any possible valid answer is a subgraph of a solution generator. It is preferable to compute solution generators than individual answers because they are easier to compute and store while preserving the possibility of computing precision and recall for an RDF keyword search system. However, computing all solution generators can also be computationally expensive. There can be too many seeds combinations and paths between seeds. Let's see how one can optimize this process. The optimization heuristics are based on 5 questions. Are all seeds relevant? Should we prefer answers that match more literals or answers that match fewer literals? Should we prefer answers in which carrier keywords occur in many seeds or answers in which keywords occur in only one seed? Should we prefer answers with many seeds or answers with fewer seeds? Are all paths between seeds relevant? We refined the original steps of the method, taking into account these questions. Instead of computing all seeds, one computes only the set of the most relevant ones. Then, one computes the power set of this reduced set of seeds. Third, one selects sets from the power set with the greatest keyword coverage, less keyword repetition, smaller size, and the most relevant entities. Finally, for each set S, select from the power set, compute all paths between each pair of seeds in S. Limit the paths to distance 4. Now, let's talk about the experiments we've done to assess the method. We assessed the answer generation process only. We didn't assess the query generation process. It's part of an ongoing work. The strategy was to choosing existing benchmarks, take their sets of queries, compute solution generators to each one, and compared their proposed ground truth with the solution generators. We aimed to respond to the following questions. Are all answers from existing benchmarks provided by solution generators? how many additional answers do solution generators contain. We've chosen the benchmarks by Kaufman and Weaver and the other by Dosso and Silvello. We've found out that we had captured, on average, 91% of the ground truth answers for queries from Kaufman's benchmark for Mondial, 52% from Kaufman's benchmark for IMDb, and 58% from Dosso's benchmark for the DBpedia. The weakest performances for IMDb and DBpedia datasets can be explained by the ambiguities in the datasets, that is, entities with similar names. The automatic method of selecting seeds could not always choose the same entities as in the original benchmarks. For example, Star Wars can be the movie used in Kaufman's benchmark, or it can be the TV series Star Wars Clone Wars with 133 episodes and exhibited from 2008 until 2020. As detailed examples, one has the Carries Niger Country and Poland Cape Verde Organization over the Mondial dataset. In the first case, we managed to find 22 more answers than in the original benchmark. In the second example, we found 111 more. The captured answers are 1 and 21 respectively. I presented an offline method to construct benchmarks for evaluating RDF keyword search systems. The defined heuristics are flexibilization points that benchmarks creators can use according to their preference. The experiments showed that we've managed to find an expressive number of additional answers and captured a good portion of the ground truth for the existing benchmarks. All experiments and datasets are also publicly available at Figshare. That's all. Thank you for your attention. You can send an email with suggestions and questions.